Welcome everybody. Welcome to Playtesting Overwatch. I'm Rowan Hamilton and I'm the lead tools developer on Overwatch. Usual reminders, set your mobile devices to silent and please fill out the evaluation at the end of the talk. Let's get started. So today I'm going to be talking about how we use playtesting as one of our pillars for tools development on Overwatch. Overwatch is built on a culture of playtesting. I'm sure quite a lot of us in this room started off in the industry with dreams of sitting around playing games all day, every day. And on Overwatch, we actually try to make that a reality. By focusing decisions about our infrastructure and our pipeline around making playtest creation simple and joining playtests as fast as possible, our tools enable a development culture like this to flourish. Establishing playtests as a pillar early has really paid off. Even now, with close to 2 years of post-launch content in the game, a developer can test their changes in a match with 12 other players in a matter of minutes. And the best part is there really isn't a whole lot of magic involved in this. A lot of what makes this possible is just designing with playtesting in mind and making simple technology choices to meet those requirements. Today, I'm going to talk about 3 core pieces of our playtesting pipeline: modular builds, playtest creation, and content distribution. So firstly, why did we make playtesting one of our pillars? Well, a lot of the early design emphasized the following points. Overwatch is a multiplayer-only title. It's heavily focused on teamwork, and we're aiming to be a highly competitive shooter. Now, historically on the tools team, we were focused on optimizing the production of individual pieces of content. But looking at what we had laid out as the core of our game, our existing goals on the tools team didn't really achieve what the design team were after. The problem was that design requires context. How does a hero or ability or map feel when I'm in a game with 11 other people? Until we get that true in-game experience, it's really hard for us to judge success. So it quickly became clear that a good playtesting pipeline was going to be critical. So we've established why playtests are going to be really important to our game. What do you actually want the workflow to deliver? Firstly, we want you to be able to playtest as soon as you save. There shouldn't be any additional hoops to jump through to start a playtest compared to just firing up the game. They should be easy to create and to share. Sharing is the really important part here. Just as we don't want any additional barriers to creating a playtest, we also need to eliminate anything beyond just clicking one button to join. Being easy to join isn't enough though, it also needs to be really fast. We don't want to be in the situation where we have 11 other people sitting around waiting in a match for the last person to download the build or some content or anything else. Every second here really counts. And lastly, we're looking to make sure that what we experience on a day-to-day basis as developers is as close as possible to what our players are going to experience when we release the game. Summary, we want less sad designers sitting around shooting at bots and more happy designers shooting at each other. This isn't going to be terribly easy though. So the main challenges we're going to face delivering this are, at any moment we're going to have several active branches and we're going to have users distributed evenly throughout them. Any branch could have dozens of potential builds and we can't rely on users having the same build or even the same branch required for a playtest. Server stacks for modern games are pretty complicated. Running a game of Overwatch is going to take at least a dozen different servers to all be spun up and configured correctly. We've got a pretty large amount of content. A full build will have a content footprint of upwards of 20 gigabytes, made up of hundreds of thousands of individual resources. Downloading anything other than a small fraction of that is going to take too much time. And we need to share any local content changes without impacting on other users. Before I jump into how we solve these challenges, let's take a quick look at the final workflow. So from the creation side, we bring up our Create Playtest UI, configure some options, and get going. At this point, we download solely the executables needed to start the server stack and run a quick validation on our data to make sure that it's ready for playtesting. Once that's done, we start to spin up the server stack, and in just a few seconds, we will be ready to have people join. If we're joining a playtest, we'll first go to our list of active playtests and pick the one we want. We'll download just the executables we need, so it'll only take a couple of seconds. At this point, the client will start up, and we'll stream in whatever resources we need directly from the playtest host. We'll go through our normal UI flow to get into a game. You can see we've got an event active at the moment, so we get toast notifications for that. And even internally, we still put people into the matchmaker. This is to make sure we get balanced playtests.
Welcome to Ayutthaya.
And at this point, we're ready to playtest. So the first piece of technology that goes into making that happen is what we call modular builds. We produce upwards of 50 builds a day. These are spread across 3 to 4 development branches and 1 to 2 live branches. We're relying solely on automated testing to make sure these builds are usable before releasing them to the team. Any build from the last 2 weeks might be in use. Content creators will grab a build whenever they want, rather than at regular intervals. Consequently, very few people will be running the same build, but we want to be able to run a playtest on whatever build a user is currently using. This means any given playtest could happen on one of over 500 potential builds. Early in development, we quickly found that downloading a build to join a playtest was just going to take far too long. Users could easily spend 5 to 10 minutes downloading just the build required to join a playtest, and at the same time, our build sizes were growing rapidly. This was killing off that spontaneous playtesting workflow that we were looking for. Build features help us to resolve this. Our modular build system separates our builds into features based on their functionality. Depending on which action a user takes, we only download the features required to satisfy the user's needs. Let's take a look at the features that make up a standard development build. So first is the tools feature. This basically encompasses our editor, data compilers, and a couple of other utilities. It's about a 200 megabyte download for the users and is the first feature that they'll grab when they start working with a build. Next are the Windows servers and Windows client features. Each box here roughly represents the download size to the user. So servers check in at about 400 megabytes, the client at about 200. And the last feature in this type of build is automation, which just covers our build validation tests. So other build types can include many more features. This is what we term a unified build. Again, each feature's size is proportional to its download size to the users. You can see here we've got over a dozen different features for various platforms, each of which might contain dozens of executables, configuration files, and other metadata. What you're looking at here would be about a 20 gigabyte download. And none of these features even include data, which is separated out into its own feature. You can see by cleanly partitioning our builds into features based on their functionality, we're allowing users to download just a small fraction of the entire build based on their exact workflows. So features provide a great abstraction for the tools. We generally don't care what files are in a specific feature. We simply need to know when we should download it based on users' actions. Modular builds massively speed up both build creation and distribution. Builds can contain very few modules, so they can be generated quickly. 90% of our builds are just going to be tools, client, and server. Those will take about 30 minutes from being requested by a programmer to being available to the floor. But regardless of how many features a build contains, the cost of the user doesn't change. They only ever get the features they need based on their exact workflow. Okay, so our builds are now separated into nicely consumable pieces. It's time to start making some playtests. So Tools Tray is our launcher application. It's the central hub of all our development, whether you're a programmer or a content creator. It's how users interface with our build system, allowing them to control which branch and build they're working in, and what functionality is available to them in their current build. Again, features are downloaded on demand as the users initiate actions that require the feature. Most of the functionality in Tools Tray is driven by scripts. Each feature will contain scripts which Tools Tray will discover dynamically. Scripts will range widely in complexity. They'll go all the way from launch an application all the way through to configure and launch a full service stack. You can see the image on the right. The highlighted section is built from scripts available in the user's current build. And the script system allows us to be a lot more data-driven, minimizing the need for us to update our launcher and the amount of logic that's baked into it. Okay, so we now have all the ingredients we need to start quickly making playtests. Modular builds make it fast to download just the parts of the build that we need. Scripts provide functionality for those build features. In this case, we're going to have a script which will handle Playtest Creation, and we'll do that for the Windows Server feature. And Tools Tray ties all of this together, integrating playtesting into the same UI developers use for many of their other daily tasks. So, Playtest Creation is initiated by Tools Tray. You can see on the right here what users are presented with when they go to create a playtest. All the functionality is still contained within the script, though. One thing we learned from this UI is that users actually like having as many options as possible. It seemed like a really good opportunity to make a much simpler, cleaner UI with most of the options that users rarely use hidden by default, and then like a manual step to add additional parameters when you actually require them. Feedback to the concept was really positive. But once we actually put it in users' hand, they didn't actually like that compact version. They missed being able to eyeball all of their settings just to quickly confirm that things were set up how they wanted. We quickly revised that design, and what you see here has the options that are always important in a fixed section at the top. While everything that was hidden by default in the previous version is now listed in the bottom of the UI under a section called Optional Parameters. Okay, now that we've gathered all the information we need from the user, we need to actually stand up a service stack. Tools Tray knows that it needs to run the launch playtest script. It will query that script to see what features it needs and see that it needs to download the Windows Servers feature. This feature contains all the executables required to run a service stack. Once that feature is downloaded, Tools Tray will pass the settings to the launch playtest script. At this point, there's actually surprisingly little for us to do because our server team is pretty awesome. In development, the server stack is configured by a single JSON file called a server config. We take a template config file, inject additional data based on what the user has provided with us, and pass that to a process controller application which does the hard work of actually spinning up all the required servers with the correct command lines. And the entire server stack is run locally on a user's machine. There are very few external dependencies in the entire system, which makes running playtests for very old builds generally a breeze. Okay, so we have a server stack up and running on our machine. Now we need to get people to actually connect and join. So part of each server stack is a lobby server. It's the server players first connect to when they go to join the game. When we're running this internally, that lobby server will send out a UDP multicast to let people know that it's available. This broadcast will contain all the information required to join the playtest. What build and branch the lobby is running, what command lines to add to the client, and where to get data for the build. Tools Tray displays all the lobbies in a single join playtest list. And alternatively, you can join a playtest via a simple link. This is also handled by Tools Tray, but it's a much more convenient method when trying to organize a playtest via email, as a single click from your email client will take you directly into game. Once you request to join, Tools Tray will download the required features and launch the client with the arguments specified by the lobby. Joining only requires downloading the client executable for the playtest, which is generally going to be around 100 megabytes or so. If you're still paying attention, you probably noticed that we just downloaded an executable. We don't have any data at all yet, and that's kind of important. Let's take a look at how we handle content distribution to resolve this. So one thing the lobby does provide to us is a manifest. A manifest basically tells us about all of the content that is in a build. All our resources are identified by a GUID, and the manifest provides a mapping from a GUID to an MD5 hash of a resource. This MD5 is what we use to actually load content into the game. All our data is stored locally in a content addressable storage container, or cask. This container uses the hash of the content as the key, which means you can have multiple versions of the same resource in the container, and it also takes care of only storing a single copy of duplicated resources. We share a single container across all builds. This means if you've downloaded a piece of content once, you don't have to download it again when you get a new build. And this is also the same format we use for the live game. So this minimizes the number of weird forks we have in our resource management code in development. So we require no data before launching. The mapping of GUID to MD5 is sufficient. When the client goes to load a resource, it will resolve it to an MD5, and if the resource is not already in your cask, we just HTTP stream it from a content server, which is also specified by the lobby. This means when you go to join a playtest, you only have to download content that you've never seen before and is used by the playtest. Let's quickly walk through a client loading some playtest data. So first, the lobby directs clients to a manifest used to load content. When the client goes to load a resource, it will first try and load it from its cask. If this fails, it will send a request to the content server, which will stream the resource to it, ready to be loaded immediately. The client will also asynchronously write that resource to its cask, so it's available on future runs. When running a playtest with local changes, there are some important differences. Firstly, instead of pointing at a fixed manifest of content, the lobby server now points clients to a data build server running on the host machine. This server tracks local changes and can provide a manifest that will incorporate those changes. Things proceed as normal, with the client first trying to load content from its cask. However, if it fails to load, it will first try to download it from an HTTP server running on the host machine. Compiled versions of local changes will get streamed from here. If a resource is not available, the host server will redirect to the global server. As in the previous example, this resource will just be streamed back to the client, consumed immediately, and then lazily written to the cask again for future runs. So, what are the benefits of having a system like this in place? It would be more efficient to just start up a game instance and shove everyone directly into it. We'd have to download and launch fewer executables, there would be significantly less configuration, and people would actually get into the game faster. That's true, but many of the benefits we get from having all playtests feel as much like the live game as possible outweigh the marginal costs to efficiency. Firstly, we have a single workflow for testing every type of content in the game. It doesn't matter if you're working on the lobby screen, a hero, store, profiles, chat, anything else. Making a playtest will let you test any feature in our game. This is obviously great for QA. Bugs that can't be reproduced easily at their desks are rare. Most test plans can be completed without packaging a full build and deploying to a test server. and there are hardly any surprises at the end of the patch cycle when we start testing actual final package builds. The second point is that there are a lot of features that are surprisingly useful during development. I think the best example of this is that we previously didn't have persistent player profiles in our development playtests. This meant that the matchmaker couldn't establish an MMR for developers, resulting in horribly uneven matches. This is obviously really bad for testing game balance. To resolve this, we changed the playtest configuration to bring it much closer to the live environment, using an internal Cassandra cluster that the matchmaker can use to track developers' MMRs and actually start making balanced playtests. It also helps keep everyone aware of the state of the game. What does the login experience feel like? What new content is showing in my lobby? Are there any new skins for me to equip? If you play Overwatch, you know that the experience from launching the client to actually getting in a game is fast and smooth and visually appealing. This is largely because everyone on the team goes through this flow for every playtest. We experience it multiple times per day, every day, and so we're kind of forced to improve it. So as we iterate on this system, improve the speed and usability of it, some surprising things started to happen. The process of making and joining a playtest was so streamlined, it became the primary method of testing any content. Running a client by itself started to become more of an edge case. This is somewhat due to certain features not being available when you're running a client by itself, but it's more so because team members were so often using playtests to collaborate and help test each other's work that it really starts to become instinctive to just run your own playtests whenever you want to test something. At this point, the playtest UI is so extensively used, we had to actually create an option to create private playtests, just so the list of available playtests to join was reasonably sized and not filled with noise. So what are our results from this? Creating a playtest is really fast. You have a small download for the server stack and no packaging or uploading step of any kind. You can have a playtest going in just a couple of minutes. There are lots of options to let people configure their playtest to test exactly what they're interested in. Playtests are immediately visible to the entire team. A single click is all it's going to take you to get into game. It generally takes a couple of minutes to get a full 6v6 match going. The biggest bottleneck at this point is letting other people know that you want them in your playtest. Email is a really bad medium for trying to communicate this information and get people together quickly, but we've started working on some improvements in this area. And we get constant testing of the full server stack. This uncovers so many bugs that we just wouldn't see until later in development, and also things that we wouldn't see if we just put people directly into a game instance. It really also helps us stay really close to that player experience that we're after. So what can you take away from this? Avoid monolithic builds. Divide your build outputs into features based on your usage patterns. Allow your tools to inspect your builds and determine what functionality is available to the user and have a minimal download. Make sure your resource pipeline can only load content that it needs. Less content means faster and more frequent playtesting. Store your content according to its hash. This automatically takes care of deduping identical resources and eliminates a whole category of issues that come from using names or versions anywhere in your pipeline. And share that storage across all of your builds. Even on really large teams, the amount of content that changes on a day-to-day basis is dwarfed by the amount of content that's going to stay the same. Again, every second that you add to joining a playtest is additional friction that is going to discourage people from joining again next time. So our playtest system is the most important part of our entire pipeline. It's less about measurable productivity improvements and more about instilling a culture on the team where we constantly play our own game because there's no barriers to doing so. This allows us to iterate as a team. We avoid becoming lost in the production of individual pieces of content and instead focus on making our game fun. Thanks. Any questions?
Hello, that was a super exciting talk.
Thanks.
Two things that I sort of question. With all the focus on playtesting and having 12 people involved, how are you guys sort of managing that not being sort of a huge time-consuming thing during the day, in addition to getting their stuff done?
It is a huge time-consuming thing of the day, but it's something leadership on the team strongly encourages because we think it results in a better final product. So we just take the hit of spending an hour or two playing the game every day.
Cool. For Cask, with all of the data coming through, how were you guys, what retention strategy were you guys doing for saying, hey, this hash is no longer relevant, we back it out so that it doesn't fill up all their hard drives?
So as I pointed out, like the amount of content that changes regularly is actually really small. Like we patch monthly, and that patch is generally in the hundreds of megabytes. So internally, you're not growing that data set very rapidly. You'll probably put like a gig or two on that over the course of a month. We have cleanup tools that people can run, but the nice thing about it is because it's just a cache, if it gets too big, you just delete it, and you are slightly slower to join the playtest again next time. You take that one-time hit of, oh, now I need to download everything instead of just the stuff that's changed. But generally, that's not a big deal because people delete it once every 6 months or so and move on with their life.
Enough drive space that it doesn't come into
Yep,
play.
exactly. Thank you.
Thank you.
Great talk, thanks.
Thanks.
My first question is about server.
Yeah.
You mentioned that you guys are running like different versions of builds.
Yep.
So how does it match up? Like everyone runs their own server and they talk to each other? Like?
No, so only the host runs the entire stack, and then everyone else just connects to the host server stack.
Right, but you mentioned that there is like Windows server, Linux server, so I assume that there is...
Oh,
like...
so for the playtesting pipeline, we're only running a normal Windows stack. Like the only external service we connect to is that Cassandra cluster for persistence, and because that is that's by design version tolerant, because it's meant to be connected to by any version of the game.
Okay, I see, got it. Okay. And second question, it seems like Cask should be like the most frequently updated part of the game. Like I assume that it contains all the stuff like logic, all the images, all assets, right? So I assume like on every start you should download like tons of stuff if your team is working and producing this all the time.
Not really. It's like the amount of content that we're producing it's not as much as you would think once it's actually packed in a reasonable size. Like you're talking about, I've already been working with the game. What's the delta between what I'm working with and what the other person who I'm playtesting with is working in? And you're generally in the range of tens to hundreds of megabytes for that delta.
Okay, which still can take time to...
It can take a little bit of time, but generally not very much.
Okay, thanks.
Thank you.
I wanted to get an idea with all the playtests going on. Is there a form of communication to give some guidance saying, I'm changing this to test some kind of gameplay hypothesis or tuning so that and similarly, does the person who produced the build then have an observer mode to watch things or recording so that they can then take in feedback from it?
Yep. So a couple of points there. There's two main ways that stuff gets communicated. One, as I said, joining by email is very common. So generally people will put instructions in the email of like, hey, this is exactly what I want feedback on. You can also use the message of the day system, which if you play Overwatch, that will sometimes put a message of the day up if there's like server issues or there's something else. It'll just pop up a little thing when you join the game going, hey, here's some stuff. We can hijack that and go, hey, I want you to test these Hanzo changes. They're the two main methods. You can also restrict what your playtest will allow. So you're like, this playtest only allows you to do a custom game with this map and with this hero pool. So people are kind of forced into testing what you want them to force. Is there anything I missed there?
No, that was good. Thank you.
All right, great, thanks.
Hi. I was wondering, can you invalidate assets while a playtest is running?
Sorry, last question. I'll go to the wrap-up room if anyone has any more questions. Technically, yes, you can. We do support hot reloading during playtests. It doesn't happen very often, and generally we discourage it because hot reloading with a server stack and 24 people all talking to each other, getting the synchronization right there is oftentimes difficulty, and we'll get a lot of desync issues, and scripts will freak out because entities don't exist on one client and on the other. So it is there and available if people are brave. We generally say if you do this, you're in unknown territory.
All right, thanks.
Thanks. I'll grab you later. You can just come up and chat. We're going to go. Thanks.